Okay, so first things first, since I want to give you guys enough time to actually do the work in class, I'm going to kind of breeze through this one. Pablo is mixing all this, and they gave you a balanced equation with the reaction. First, they want you to find the limiting reactant. First thing you do is underneath or on top, around your reaction, I want you to go ahead and write down the amount that is given to you. They tell you that you got 3 grams of strontium hydroxide, and they tell you also that you got 2.5 grams of iron nitrate. Remember, we have to actually calculate things out. So, I'm going to figure out which of the two products I'm going to use to predict, right? Well, the second part of the question is that it wants me to find out how much of the precipitates produced, right? Between the two, this is precipitate because I can see that S at the bottom. Whenever you see that S, that's your precipitate. So if the question is already asking you how much of this are you going to form, I'm going to just go from here to this guy, here to this guy. First prediction and second prediction. Pretty simple, right? So I don't have to try to retrace back and try to find products for the other guy. I'm going to start with 3 grams of strontium hydroxide. I have to go through the whole thing of converting to moles, to the mole ratio, and find this guy. So it ends up looking something like this. Grams of strontium hydroxide at the bottom, 1 mole at the top. I get this number from where, guys? Periodic table. I'm going to add up strontium and 2 times the oxygen's mass plus 2 times the hydrogen's mass. Follow with the notes. I'm going to use my mole ratio to determine how many moles of FeOH3 I'm going to produce, which I will then convert to grams because it wants me to find the amount of precipitate formed. I'm going to assume that they're talking about grams. So I'm going to convert the moles of FeOH3 into grams by using its molar mass. When I finally get the answer, I get 1.8 grams of iron hydroxide. What that's saying is that if I had 3 grams of strontium hydroxide, that's enough to make 1.8 grams of iron hydroxide. Am I done yet? No, I have to make the next prediction, correct? Alright, so, again, there is enough strontium hydroxide to make 1.8 grams of iron hydroxide. Let's make the next prediction. We're going to use now iron nitrate. Do the same thing, convert this to moles, use a mole ratio to predict how much iron hydroxide you're going to form, and you're going to end up getting something like this. Remember, again, the grams for every 1 mole, these are the numbers that you get from the periodic table by adding up all the elements' masses. Final answer is 1.1 grams of iron hydroxide. I'm going to give you a minute to write this down. Alright, so when you do the math, you get 1.1 grams. Between the previous prediction that gave you 1.8 grams versus this prediction that's giving you 1.1 grams, which one do we like better? 1.1. Why is it that we like the 1.1 better? Because it's less, right? We always go with the smaller prediction. So we can say that the 1.1 gram is going to be your theoretical yield. If that's your theoretical yield, that means limiting reactant is going to be iron nitrate because iron nitrate is the one that gave you the 1.1 grams of iron hydroxide. Now, last part of the question is asking, once we figure out what the limiting reactant is, I want you to find out how much of the excess reactant is left over. So let's just recap. Limiting reactant is iron nitrate. So that makes which one the excess reactant? SROH2, right? Strontium hydroxide. So this is what I was showing you yesterday. Now, for you to figure out how much is left over for strontium hydroxide, you need to figure out how much you're going to use up to begin with. Right now, you got 3 grams. So, let's start. Limiting reactant is iron nitrate. So I'm going to say, okay, so if I had 2.5 grams of iron nitrate, I want to know how many grams of strontium hydroxide I'm going to need. To figure that out, you produce the same process using the mole ratio converted to moles. So let's start with converting to moles first. Same mass you already knew. But this time, instead of going to iron hydroxide, where am I going to go to? Strontium hydroxide, because that's going to tell me the ratio of strontium hydroxide I need for iron hydroxide. Because I'm looking for excess reactant, I'm going to have to go ahead and turn this back to the other reactant. So mole ratio between iron nitrate and strontium hydroxide ends up being 2 to 3. So here's my ratio. I'm probably going to have to find this in grams. So let's find the mass of it. Here's 1 mole for every 121.64 grams of it. But we're just going back to strontium hydroxide. Previous ones, we were predicting how much iron hydroxide was forming. But this time, I'm trying to figure out how much of the strontium hydroxide I need to use. Right. No, this. Okay, so this tells me that if I have 2.5 grams of iron nitrate, I'm going to need to use 1.9 grams of strontium hydroxide. So if I'm going to need to use 1.9 grams of strontium hydroxide, and I had 3 grams to start with, how am I going to find the excess? I'm going to have to subtract it from the original. So again, this is recapping what we're doing. If 2.5 grams of iron nitrate reacts, then 1.5 grams of strontium hydroxide will react or be used up. Why is it 2.5? That's my limiting reactant.
So you subtracted what, 3.0?
I have to subtract it from 3.0 because that's my excess reaction.
You subtract it, you get 1 over 3.0.
So I'm going to have to go ahead and do 3.0 minus 1.9, which gives you 1.1 grams of strontium hydroxide that did not get reacted. Yes. Try to listen. I know you guys are still copying it. Oh, sorry, I'm going to go back. I'm going back. Here it is. Where is my pencil? Alright, watch what I'm doing. In order for me to determine the limiting reactants, I had to use this guy to predict this product. And then I'm going to have to use this guy to predict this product. This process, 1 and 2, determine which one is a limiting reactant. After doing this, we chose whichever one gave you the smaller product. Then, we have to say, okay, but I want to know how much of the excess reactant is left over. So then, I'm going to use the limiting reactant that I found, in which case it's this, and I'm going to go back to the other reactant. That is step 3, which is going to tell you how we can determine the amount of excess reactant. So there's really a 3-step process here. First, you have to use one of these to go to product, one of these to go to product. Figure out which one the limiting reactant is. If this one, okay, well fine. Then use the limiting reactant to figure out how much of the excess reactant you have left over, because that's the amount that you're going to end up using up. Figure out that amount, subtract it out from the original of the excess reactant you have left.
So you subtract that from 1.1.
You mean subtract 1.9 from 3. Okay. Alright, so this video is online. Just a reminder that you have probably Tuesday is going to be your pop quiz, because on Monday I would like to answer a couple of questions from the worksheet that you're doing. I'm not going to be answering every single question. We just don't have time for that. So, over the weekend, you are going to have to do some of the problems. But again, this is not due until Wednesday, just in case for some of you guys who need to come see me for help. Alright? You have the rest of the class period to work, and good luck. And for people who just came in, I want you to watch the video on your phone or something.